Hi, I'm Audrey Moran, a PhD student in Dr. Shannon Polini's lab at Bowling Green State University. I'm excited to tell you about this work, which informs us about the decomposition of insect carcasses and the response of ground invertebrates and soil microbes to the carcass addition. We used conventionally managed cornfields as the stage for our experiment with the intention of asking a question beyond just what happens to ground invertebrates and microbes when you add dead insects. We wanted to ask a question that would also address widespread problems resulting from excess nutrient runoff, such as toxic algal blooms. We asked if adding a labile detrital source, such as insect carcasses, could act as supplemental fertilizer that would also attract beneficial insects to aid in decomposition and nutrient cycling in agricultural fields. These invertebrates break down and process detritus in a way that can make it more accessible to microbes, who do the really heavy lifting when it comes to decomposition. You may wonder why we would want to attract invertebrates that will speed the breakdown of detritus when we already have excess nutrients running off from agricultural fields. After invertebrates are established, they may not only immobilize nutrients in their body, but aid in breaking down detrital resources so that less synthetic fertilizer is necessary, which readily runs off. We collected adult mayflies, which emerge in massive swarms like some other insects. They mate and then they die overnight. Then they're swept up and disposed by the city and residents of lakeside areas. We added these mayflies, which we collected before their death, to plots in Northwest Ohio cornfields. Additionally, we had plots where we added corn litter and half corn litter, half mayflies, to see if the response to mayfly addition would differ on fields where farmers leave corn residue. We ran the experiment for 7 weeks, measuring ground invertebrate activity weekly. Every 2 weeks, we measured soil nutrients and microbial activity such as biomass, respiration, and carbon, nitrogen, and phosphorus acquiring enzymes. Mayflies, but not corn litter, increased abundance of ground invertebrates, especially scavengers. Immediately and throughout the experiment, even after mayflies were no longer recognizable on the plots. Predators also responded positively to the addition, but to a lesser degree, and herbivores did not respond. We did not see an increase in microbial biomass or the enzymes we measured. However, we did see an increase in microbial respiration in response to the mayfly addition, suggesting that microbes were making use of the mayfly carcasses. Interestingly, there's a positive relationship between invertebrate abundance and respiration, and a similar relationship between invertebrate abundance and soil nutrients. This relationship occurred across all treatments, which suggests that invertebrates are facilitating microbial detrital breakdown. Altogether, our results suggest that adding detrital resources to farm fields would recruit beneficial invertebrates to aid in decomposition and nutrient cycling, thereby reducing the need for synthetic fertilizers. Thank you very much. You can email me at audreym@bgsu.edu if you have any questions.